Hello students, in the last class we have discussed what is continuity, definition of continuity and some types of discontinuity, and we have seen some problems which can be expected in your board's questions. One is how to solve questions regarding if a function is continuous or not, check if a function is continuous or not, or they may ask to show that a function is continuous, or another type of question is if a function is continuous, then find the constants a and b so that that function is continuous. These are the different varieties of problems that can be expected in your boards for continuity. Now we will discuss what is differentiability. Now we will discuss what is differentiability of a function. Okay, for understanding differentiability, first we will understand what is a derivative and when a function is called a differentiable function, and what is the geometrical meaning of derivative or differentiable function. We will discuss this one by one. Right? Definition of derivative and first principle derivative. First we will see what is the definition or meaning of derivative. Let f be a function defined on neighborhood of a in a real number a, then f is said to be differentiable or derivable at a. Then what is the condition? If a function is to be differentiable, then the condition is limit x tends to a, f of x minus f of a divided by x minus a exists finitely. What is the keyword, students, in this? Limit x tends to a, f of x minus f of a divided by x minus a. It is vague, you don't need to understand this better, so I will explain geometrically what it means. And another keyword here is this limit is 1 and another is finitely. That word is very important. Now we will understand this geometrically. What does that mean? I will again explain. Just write this limit x tends to a, f of x minus f of a divided by x minus a exists finitely. This is a finite value. Now we will understand this geometrically what it means. So for understanding this, let's take any arbitrary curve. This curve is f of x. This is x axis and y axis. Now what does this limit mean? Limit x tends to a means x is very close to a, but it is not exactly a. So what we will do? Assume certain point. Let this point be a, and we will take some other value. Let this value be some x, small x. That means these two values of y will be, this will be f of a and the other value is f of x. Correct now? This is easy to understand. Let at a point a, function value will be f of a. At a point x, its function value will be f of x. Now what does this limit mean? Forget about limit. What does this term mean? F of x minus f of a. F of x is this y value, f of a is another y value. F of x minus f of a is nothing but the difference in y value, x minus a. That gives the difference in x value. That means if we draw a triangle, this value is nothing but difference in y. Del y means difference in y. That is nothing but f of x minus of f of a. And this distance difference denote difference in x, del x, which is nothing but x minus a. Yes, no? So this is understood. And what is this value? This is a right angle triangle, because this line is parallel to y axis, so this forms a right angle triangle. And for a right angle triangle, This is a perpendicular side, let this be theta. Then this is a perpendicular side and this is adjacent side. Opposite side by adjacent side is given by tan theta. So this line actually represents the slope of this line connecting the 2 points. Yes, no. And now what is given? Limit x tends to a. That means this x, the value x is getting closer and closer to a. That means when x is getting closer and closer to a, what will be f of x? F of x will get closer and closer to f of a. Yes. So when x is getting closer to a, f of function becomes, when it gets closer and closer to a, this line actually will be drawn like this. Yes, not. And what is this line? It is tangent. So this line secant of the curve actually becomes a tangent to this curve. And what is given? This limit, which defines what is the slope of tangent line. This term actually, limit x tends to a, f of x minus f of a divided by x minus a, gives actually the tan theta value. This will be theta and slope m is given by tan theta. So this tan theta is nothing but the slope of tangent and this should be finite. Then we can call a function to be differentiable and the value of derivative is nothing but actually the slope of the tangent. Yes, now. So what does this actually mean? Limit x tends to a, f of x minus f of a by x minus a is finite. That means this represents the slope of tangent having finite slope. So this is, that means when slope of tangent, a tangent has a finite slope means there should be a unique tangent and it should have a finite slope. In other words, we can write this as geometrical meaning of derivative is nothing but unique tangent having unique tangent with finite slope. This is the meaning of derivative. You just need to remember this, students. Just remember these two keywords. All the derivative problems is only based on this. So what is it? Unique tangent with finite slope. That is it. What is unique tangent? That means you draw a single tangent that has only one slope. You can't have a tangent with more than two slopes, right? And why do we have to tell if the tangent is unique or not? I will tell another example. This x point, we have considered this x point taken to the right side of A. Suppose we can also take the x point to the left side of A. Then this limit is actually nothing but the right hand limit. Yes. So f of x, when it gets closer and closer to A, from this given diagram, we have actually given the value of right hand limit. This is x tends to A plus. Suppose we take the value of x to the left hand side and this x gets closer and closer to A, then that will give us the value of left hand limit. Correct? No? From left hand side, when x approaches A, what is the value of function? That will be left hand limit. Now those two limits should be equal. Only then we can say limit x tends to A, f of x minus f of a by x minus a exists finitely. That means, what does it mean? F of x minus f of a by x minus a, which is value of del y by del x. When limit x tends to a, that means left hand limit and right hand limit should be equal. Only then we will say limit exists. So limit exists finitely means left hand limit should be equal to right hand limit. That means left hand derivative, that is slope of tangent from the left hand side and right hand side should be equal. That is the meaning of it. Do you understand? So what does that mean? Left hand derivative as well as right hand derivative should be equal. Left hand derivative should be equal to right hand derivative. And what does the left hand and right hand derivative mean? From the left hand side, what is the slope of tangent? From the right hand side, what is the slope of tangent? Right. So You just need to remember these keywords: unique tangent and finite slope. That is the meaning of geometrical meaning of derivative. Okay, we will start with the definition. This is the meaning. Okay. The limit is called a derivative or differential coefficient of f at a. So this limit value is actually called the derivative of the function. So what is the derivative of function? It is nothing but slope of tangent. And the slope of tangent should be a finite number. Okay. Now the slope should be finite number. That means we will consider different scenarios. Let's consider a function like this. Any arbitrary function. This is first type. This is second type of function. This is third type of function. Now when we observe these three types, what is the left hand and right hand derivative? We need to find the derivative at this point. That means at A, what is the left hand and right hand derivative? When we take left hand derivative, that means from the left hand side, whatever value that is near to A, take this point as well as this point, which is the function value, and the values that connects the nearest points and it touches those points. That line is called as a tangent. Yes, what is a tangent, students? Tangent is nothing but a line that touches the curve at only one point in the given neighborhood. So in the neighborhood of this point, which is nothing but this value is a neighborhood of A and this value will be another neighborhood of A. So in this neighborhood, this line, a line that touches the curve at only one point. It should not intersect at more than one point. So that means when we draw a tangent to this curve, that gives us nothing but the value that is very close to that function value on the left hand side is this one and function value is this one. That means when you connect a line through this will give us the left hand tangent. LHT means left hand tangent. Tangent drawn from the left hand side of the function value. And the value of tangent from the right hand side, that will be this point is defined over here and the function value from the right hand side is here. So tangent line will be this one. So this gives us the right hand tangent. Now when we observe this, the slope of tangent is different for both sides. That means this function is not differentiable at A. That is the meaning of it. So what does the meaning of differentiability? Differentiability means tangent should be unique and it has finite slope. Here tangent is not unique. That means this function is not differentiable. In other words, when you observe any discontinuous function, when we have to draw a tangent, left hand as well as right hand tangents will be different. Yes or no? Do you understand? Because tangent is a line that touches the curve at only one point in its neighborhood. Here we can't draw a tangent that is unique from both left hand and right hand side and it has same slope. That is impossible. So what it means is, whenever a function is discontinuous, that means we can't have a unique tangent at the point of discontinuity. That means this function will be not differentiable. So any function that is discontinuous at a certain point is not differentiable at that point. Now what about the second case? Let this point be A. Left hand tangent as well as right hand tangent will be this line. Yes, at any point of this function, left hand as well as right hand tangents will be same. That means its slope will also be same. That means this tangent is having unique slope and a finite slope, and tangent is unique. So this means this function is differentiable at that point. That is the meaning of it. Then what about the third case? Let this point be A. Here can we draw a tangent that is unique? Yes, but it has a finite slope or not? No, because this curve increases its slope exponentially. It is having a sharp increase in its slope. That means this slope of tangent is actually infinite, because this line is parallel to y-axis. That means when slope increases exponentially, this slope is actually infinite. Tangent value is, it is actually a vertical tangent. So whenever there is a vertical tangent, that means this function does not have a finite slope, hence it is not differentiable at this point. So this function is not differentiable, this function is differentiable, again this function is not differentiable. Reason, it does not have a finite slope. Here tangent does not have a same slope, here this tangent does not have a finite slope. Here tangent has unique slope and a finite slope, so this is differentiable. Now we will consider another case. Take for example mod x curve. Now tangent at this point will be line like this and line like this. That means tangent are different. So that means this curve has actually two tangents. That means slope of tangent is different from both left hand as well as right hand side. Hence this is not differentiable. In short, for a function to be differentiable, that function should be continuous and it should have a unique tangent with a finite slope. And whenever a function has a sharp point in the curve, at those points the function is not differentiable. And whenever there is a jump in the curve or a function is discontinuous at certain points, at those points the function is not differentiable. That is the meaning of it, right? Okay. So the limit is called a derivative or differential coefficient. That is the slope. This value actually gives the slope of tangent. It is denoted by f dash of a. That is nothing but the derivative at the point a. If f is differentiable at a, then f dash of a is given by limit x tends to 0 f of a plus x minus f of a divided by h. This is another way of writing slope of tangent. Actually both are same. X tends to a, f of x minus f of a by x minus a. That is equal to this slope. Here instead of writing x and a, here what we did is limit h tends to 0 f of a plus h. That means this value is actually the value of function which is very close to a plus h minus of f of a divided by a plus h minus a. That will be h. This is another way of writing the slope of tangent. Now what is the definition? Let f be a function on the neighborhood of real number a, then f is said to be right differentiable at a. Right differentiable means right hand derivative, right hand tangent. A limit x tends to a plus right hand limit slope of tangent exists finitely. The limit is called the right derivative of f at a. This is denoted by f dash of a plus. Just like how we write in a right hand limit f of a plus, here it is f dash of a plus, right hand derivative of the function. Definition: function is defined in the neighborhood of a, of any real number a, then f is said to be left differentiable. That means left hand tangent exists and it has a finite slope. So this means left hand limit x tends to a minus f of x minus f of a by x minus a exists finitely. Then we can call that function is left differentiable at the point a. The limit is called a left hand derivative of f at a. It is denoted by f dash of a minus. So what is the condition, students? From the observation, what we have discussed till now, there should be a unique tangent, that means right hand tangent and left hand tangent both should give the same tangent, and it should have a same slope. That means, so what it means is the tangent should have a unique tangent with finite slope. That means left hand tangent as well as right hand tangent both should be same. So limit is called the left derivative of f at a. It is given by f dash of a minus. Note, f is a function defined on the neighborhood of a of a real number a. Then f is differentiable at a implies f is both left as well as right differentiable at a. That means slope of left hand tangent and slope of right hand tangent both should be equal. Or left hand derivative and right hand derivative both are same. F dash of a plus equal to f dash of a minus. Another definition. Let f be a function defined on closed interval a to b. Then f is said to be differentiable on this interval if f is differentiable at c, where c belongs to open interval of a to b. That is, c is any point on the interval a to b, and if f is differentiable in an interval, that means it should be differentiable at all points in the interval. Just like how we see in continuity. If a function is said to be continuous in an open interval, it should be continuous in the entire values along the open interval. Similarly, function should be differentiable on the entire interval, open interval, and it should be right differentiable at a, and it should be left differentiable at b. So it should be right differentiable at a and b value is here, so it should be left differentiable. That means left hand tangent exists. Right differentiable means right hand tangent exists. So that is the condition here. And these two values should be finite. Let f be a function defined on closed interval a to b. Then f is differentiable in the open interval a to b if and only if limit x tends to h, f of x plus h minus f of x by h exists finitely. Again, this is same. Also, f of x equal to f dash of x equal to limit h tends to 0, f of x minus f of x by h. This is nothing but f dash of x. F dash of x is equal to this value, limit h tends to 0, f of x plus h minus f of x by h. If y is the given function, then f dash of x, that is given by f dash of x or dy by dx or d of y or y dash, not y1, this is y dash or y subscript 1. All these are same notation, that is giving the derivative of the function. So dy by dx or d capital D means differential of y, or y dash, again y dash means dy by dx or y1, f dash of x. These are 5 notations that are being used for representing the derivative of a function. Let y equal to f of x be a differentiable function at x. If we denote the change in x by del x and change in y by del y, then del y is nothing but what we have already seen in geometrical representation. So this is nothing but del y gives the difference in y values, that is f of x plus del x minus of f of x. Again we can write the derivative of a function in this format. F dash of x is equal to limit of del x tends to 0, f of x plus del x minus f of x by del x. All these are same. This is limit del x tends to 0, del y by del x. Now we will solve some problems for understanding differentiability better. And we will also discuss what is derivative by first principle. What the formula we will discuss, definition of derivative, differentiability, that is nothing but the first principle derivative. So derivative by first principle, actually that formula. By using that formula only we will derive values of some standard functions, derivatives of some standard functions. Okay, now we will see one by one. Let f is a function defined from real number to real number is defined as f of x equal to x square. Then show that f is differentiable at all values in the real number and f dash of x equal to 2x. Now for proving f dash of x, finding f dash of x, we will solve more problems using first principle method for understanding the concept better. After this, while finding the derivative of functions, these are actually taken as the standard formulas. So you don't need to solve by first principle method as long as it is not mentioned in the question. If it is given, you should solve by first principle method, then proceed. Or if it is a subjective question with higher marks, say 4 marks or 5 mark question, then use first principle method to find the derivative of the function. Otherwise, you can use directly. Okay, now we will solve few problems. Show that f dash of x equal to 2x. Now what is the derivative of the function? F of x equal to x square. F dash of x is equal to limit h tends to 0. F of x plus h minus f of x by h. We have already seen the formulas. So what is f of x plus h? F of x is x square. So f of x plus h is x plus h whole square minus x square divided by h. Now expand this. X a plus b whole square is a square plus 2ab plus b square. So it is x square plus 2xh plus h square minus x square. Plus minus x square will get cancelled. And remaining terms we have h and h square. One h will get cancelled. So this value becomes 2x plus h. Do you understand? Easy. So this is nothing but 2x plus h. So when we apply this limit, this h will also get cancelled. Why is that? Because it is a limit of h tends to 0. H is actually not 0. It is very very close to 0. So we can cancel out this h. Remaining we will have 2x plus h. And when we substitute h equal to 0, then this value will be actually very close to 2x. So what is the derivative of x square? That is 2x. This is the proof for this. So f dash of x is equal to 2x. The process of finding derivative is called the differentiation of the function or method of finding derivative from the first principle. What we did, this process is called differentiation or derivative of the function by first principle method. Next, derivatives of some standard functions. Okay, we will derive some formulas based on the first principle of some standard functions. First one, if f is a constant function, then show its derivative is equal to 0. Since f is a constant function, that means f of x equal to c for all x. Now by applying the first principle method, f dash of x is equal to limit h tends to 0, f of x plus h minus f of x by h. So what is f of x plus h? It is again a constant, same value, c minus c, which is 0, 0 by some number which is non-zero number. So answer will be 0. So what is the answer for this? Derivative of constant function is 0. F dash of x equal to 0. F of x is c implies f dash of x is 0. If c is constant, then its derivative is 0. Next is, if f of x is equal to x power n, then its derivative is n into x power n minus 1. So if f of x is x power n, then f dash of x is given by limit h tends to 0, f of x plus h minus f of x by h. That is limit h tends to 0, x plus h whole power n minus x power n divided by h. X plus h whole power n minus x power n by, we already know this. and this limit is given by n into a power n minus 1. We already know how to calculate this limit. And also, if we expand this by binomial theorem also, we can find the value of this limit. So what is the expansion? X plus h whole power n, x plus y whole power n, x plus y whole power n, that is given by summation r equal to 0 to n ncr x power n minus r y power r. Now use this to expand this. So x plus h whole power n, x plus h whole power n is given by nc0, that is 1, x power n minus 0, h power 0. Next term is plus nc1, that is n, x power n minus 1, h power 1. Next nc2, x power n minus 2, h power 2, plus remaining term, last term will be ncn, x power 0, h power n. Now x plus h whole power n minus of x power n, minus of x power n means we have to subtract x power n. That means these two terms will get cancelled out. Divided by, in denominator we have h. So divided by h means h will be common from each terms. So this will be n minus 1. So we can cancel out h from all the terms. So what is the answer? Final answer is n into x power n minus 1. So that is what is given here. This value is, this limit is nothing but n into x power n minus 1. That is the formula here. So this is nothing but n into x power n minus 1. So derivative is this. So differentiation of x power n is given by n into x power n minus 1. Remember, whenever it does not matter if it is a positive integral number of n. It can be any power, because we also know how to expand the rational powers in binomial theorem. We have discussed how to do expansion for rational powers. Again the formula is exactly same. Instead of writing nc1 nc2, we will write n into n minus 1 by 2 factorial, n into n minus 1 into n minus 2 by 3 factorial, etc. We will just expand and write whatever is power. It can be fractional also. So formula remains same irrespective of power. Right? This is the derivative of x power n. For example, if we have to find derivative of x power 2 by 3, then what is the formula? Take the power and write in before. That is 2 by 3 x power 2 by 3 minus 1. What is 2 by 3 minus 1? Minus 1 by 3. So answer is 2 by 3 x power minus 1 by 3. Next is, if f of x equal to e power x, then f is differentiable at all values and f dash x equal to again e power x. Now if f is equal to e power x, what is f dash of x? F of x plus h minus f of x by h, limit h tends to 0. That means e power x plus h minus e power x divided by h. Substitute f of x value here. And e power a plus b, e power m plus n, that is nothing but e power m into e power n. So this can be written as e power x into e power h minus of e power h divided by h. In this e power x is common, so we can take e power x outside, and the remaining term we have e power h minus 1 divided by h. Now we can apply the limit separately. E power x, it is same, e power h minus 1 by h. Any number e power some 0 minus 1 divided by same 0. That value of limit is actually 1. We have seen in limits. This is a standard limit. So this value becomes 1. So the function value is, derivative of the function is nothing but e power x. As this limit is 1, derivative is e power x. Next theorem, if f of x equal to a power x, show that f is differentiable and f dash is a power x into log a. Again, this is similar to e power x. F dash will be this value. So again, instead of e, we have a power x plus h minus a power x divided by h. A power x is common. Remaining we will have a power h minus 1 divided by h. And what is this limit? This value of limit is nothing but log a. A power x minus 1 divided by x. Limit is log a. We already seen this in limits. So this is nothing but a power x into log a. Easy questions, easy proof. These are all derived from first principle. And you have to remember all these formulas. What are the formulas you have discussed till now, students? One is derivative of constant function is 0. Derivative of exponential function e power x is e power x. Derivative of polynomial function x power n is n into x power n minus 1. Derivative of x square is 2x. And derivative of e power x is e power x. Derivative of a power x is a power x into log a. Next, derivative of log x. If f of x is log x, then its derivative is 1 by x. Again, take f of x equal to log x. F of x plus h minus f of x by h. Limit h tends to 0 is the f dash of x. So what is log of x plus h? Limit h tends to 0, log of x plus h by x divided by h. This value is nothing but log of x plus h minus log x can be log a minus log b is log a by b. So this is log of x plus h by x. We can divide by x. This will be 1 plus h by x divided by h. Log of 1 plus h by x divided by h. So this limit is limit h tends to 0, 1 by h of log of 1 plus h by x. And what is m log n? That is log n power m. So this value of power which is in the which is before the log, this number will rise to the power. So log of 1 plus 1 by x into h whole power 1 by h. And what is this value of limit? Limit of log of 1 plus 0 power infinity. 1 power infinity term value is c, and whatever is there in this value near that will come into the power of e. So this is nothing but log of e power 1 by x. So which is nothing but 1 by x log e. So value is 1 by x. So what is the derivative of log x? Derivative of log x is nothing but 1 by x. Derivative of log of mod x, that is also 1 by x. Note that also. This is also very, very important. Derivative of log of mod x is also 1 by x. Derivative of log x is also 1 by x. Next, derivative of trigonometric functions we will discuss in the next class. Keep learning and keep growing, students. Success is yours line by line. ಎಂದಿಗೂ ಎಂದೆಂದಿಗೂ ನಮ್ಮ ತಪಸ್ಯ.